Hello, everyone. If you just arrived to the second day of the BA Excellence Conference, welcome. And if you've been following our previous presentations, thank you. For this subject, AI to enable touchless supply chains, I am proud to present you Ajit. Ajit is located in Toronto, Canada, and I hope that the summer has bring some warm weather to the Canada. Ajit is a lead business analyst at EPAM Systems since 2021. He has a total 15 years of experience in supply chain and data analytics. He is a data enthusiast and a practitioner and is avid learner. So welcome, Ajit, and the stage is yours.
Thank
Please.
you so much, Francisco. Thank you so much, and good morning to everyone. Morning, evening, according to your time zones. Yeah. Uh, Thank you so much. So we will. I will be like today talking on the role of AI in the touchless supply chains as Francisco has introduced. My name is Ajit. I am a lead PA with EPAM. I am currently like residing in Toronto, Canada. I have like in total 15-year experience in the supply chains and working on the data side of the supply chains like since approximately 13 years. I joined EPAM in 2021, and currently I'm working at Meta account as a BA. Uh, Before I will like start with this presentation, I would want to ask you a question. Like, can you define the touchless component in this touchless supply chains? I'll possibly take a pause if you would want to write something in the chat. So the contents of the today's presentation would be to introduce the touchless supply chain. Then we will go down to the features of the touchless supply chain, and we will also explore some of the use cases of AI in the touchless supply chain. And finally, we will discuss the role of PAs in the touchless supply chain. I will potentially use a acronym TSC for the touchless supply chains throughout the presentation. Maybe I will use them interchangeably. Let's see how it goes. Uh, so the introduction to touchless supply chain. Let's start with the introduction to the touchless supply chain. So here, I think I will try to answer my question. The primary aim of the touchless supply chain is to minimize the human touch wherever possible from the supply chain workflows or supply chain processes, right? So the touchless component is basically to substitute the human wherever it is possible. Uh, Touchless supply chains like particularly refer to the intelligent part of the supply chain management that is used to eliminate the need of the physical contact and human intervention throughout the entire supply chain process. Touchless supply chain concept is like mostly inspired from Industry 4.0, and we are here to basically nowadays in the modern days we are implementing the supply chain 4.0. Uh, Touchless supply chain, as we all know, is a modern supply chain that uses a lot of technology, and the technologies which we can use under the hood are AI, Internet of Things, robotics, data analysis, and many other technologies, basically to automate the processes to provide the maximum assistance to the human if that is not fully automatable. So in that case, the main focus of the touchless supply chain is, as I said, is to minimize the friction points from the supply chains technically. At its core, touchless supply chain uses the advanced technologies, and normally when the things are moved around, people have to handle them in the normal touchless in the normal supply chains, but which which can make things slower, which has the chances of error. But with the touchless supply chain, machines and technologies do the most of the work instead of people. Let's take a scenario how it works basically. When you or someone else orders something online, possibly a toy, the order is like received by a computer system. Robots and machines are used to move the toys around. They can pick up the toys and put them in the boxes, transport them without the people having to touch them. Once the toy is packed up in a box, the machine can print a label and put the label and address on the package, and then that is then that is put on the delivery schedule. Then the toy is like sent to your home or maybe your office, where whatever the address you have given, using the delivery trucks or even the drones or maybe even the autonomous vehicles which are fully driven by the computers. uh, and finally the toy arrives and you are ready to open and play with it, right? This is like the typical scenario which we normally imagine that touchless supply chains into. Actually, touchless supply chains have many more components than that on the business side of it, which are actually which are to predict the demand without much of the human intervention, procurement planning, order placing, production, uh, customer engagement, and many other processes basically throughout the supply chains. Uh, in in the today's like rapidly evolving world, the concept of touchless supply chains have emerged as a powerful solution to improve the operational efficiency, mitigate risk, and ensure the safety and goods of the people. Also, we are experiencing the shortage of people in many of the areas in the world, and so these are like the solutions to those kind of problems as well. Orgs are increasingly turning to touchless supply chain management to streamline their operations and stay ahead in the competitive markets. Technically, uh, the key technologies that are used to enable AI are, as we know, IoT, art- artificial intelligence, robotics, blockchain, and data analysis. IoT devices and sensors enable real-time tracking and monitoring of goods, ensuring the visibility and traceability across the supply chain. AI-powered algorithms and machine learning machine models optimize the demand forecasting, uh, stock management, route optimization, and leading to more accurate planning and efficient operations. Uh, Automation means using the machine and computers to do the task instead of human, and this helps touchless supply chain by reducing the need for people to touch or handle products, also to touch and handle the processes such as order placement or something like that. Machine and robots can handle the tasks like moving and packing items. This is more of the warehouse stuff which I am talking about, but there is like more, as I said, there is more than that actually to the touchless supply chain, which we will discuss down the line. IoT is all about the devices that can collect and share information with each other in a touchless supply chain. IoT devices can, like sensors and smart tags, are used to track products and packages. They provide real-time updates on where the things are, how they are doing, how they are being moved without needing the people to physically check or handle them. AI and machine learning use the computers to do the data analysis and learn from it. In a touchless supply chain, these technologies help in making better decisions, improving operations. They can automate tasks, manage stocks, and more effectively, and plan the best routes for moving the things around. Robots and autonomous systems can work on their own without needing people to control them. In a touchless supply chain, robots can be used to pick up, pack, and sort items. They also reduce the need of people to touch products and make the supply chain faster and more accurate. We have many other contactless technologies throughout the supply chains. Also, like nowadays, blockchains are also have a high potential to enable integrity into the touchless supply chain. As blockchain is a secure and transparent way of recording transactions. In a touchless supply chain, this can be used to track and then verify the authenticity of the product. It also helps in the streamlining paperwork and building trust between the different parties involved throughout the supply chain processes. By using these enablers, companies can create a touchless supply chain that minimizes the need for physical handling, improves efficiency, and reduces the chances of mistakes or disruptions. This is about using technology to make the supply chain smoother and safer for all stakeholders. What are some of the benefits touchless supply chain does have? So, by implementing touchless supply chain, orgs can achieve several benefits. Like, firstly, this improves operational resilience by reducing the reliance on manual processes, which are prone to errors and disruptions. Secondly, it improves efficiency and reduces the costs by eliminating unnecessary touch points and automating repetitive tasks. Thirdly, it ensures the safety and hygiene of goods, as well as well-being of employees by minimizing the physical interaction with the difficult processes. Moreover, the touchless supply chain promotes sustainability by optimizing resources by optimizing the resource utilization and reducing the waste. They enable faster response times to market demands and enhance customer satisfaction through improved order accuracy, timely deliveries, and faster collaboration and transparency among the supply chain partners. So, what are the like typical features of the touchless supply chain? So, how we can identify if a supply chain is a touchless or it's yet not touchless? It's like more of the trade traditionally, you can say. Uh, a touchless supply chain, the flow of in a touchless supply chain, the flow of information and goods is digitized and interconnected, enabling seamless coordination and communication between the different stakeholders. But I would want to say there is no set boundary which will actually set apart a classic supply chain from a touchless supply chain. So, but before that, because we were actually because this presentation is all about AI and ML applications into the touchless supply chain. Uh, I would want to ask you a question like, what do you think AI and machine learning are the same thing or they are different? Uh, as you all possibly have guessed, no, AI and machine learning are not the same thing. Machine learning is a subset of AI and has gained significant popularity in the recent years. AI is a broader term, is an umbrella term, and approaches beyond just machine learning. AI has AI consists of some of the rule-based systems, expert system, which are mix of machine learning and then a rule-based system, natural language processing. Traditionally, this was using like when I started using with the natural language processing. I think we weren't using much of the machine learning into it, but more of the idea was to do a lot of things basically without using the machine learning. But eventually, the machine learning evolved, and we started to use the machine learning within the processes. Uh, Computer vision was definitely, I think, the machine learning based component from the beginning. Robots weren't using machine learning in the beginning, I think, but then later on they also started to use machine learning. I am working with AI like with approximately 12 13 years now. I was a AI enthusiast. I always like love to build the prototypes, uh, a lot of prototypes, basically, possibly using MATLAB, Python, and also I still remember using Lisp and Prolog to build AI prototypes and applications. I have like witnessed the journey of AI from Lisp and Prolog to Python and others. Nowadays, we are using Python and many other languages which are actually changing the course. We have a lot of library and access to a lot of like AI tools, which I think we never had 12, 15 years ago. Um, okay. One thing which actually makes the touchless supply chains touchless is definitely automation. Automation and robotics is like more of a branch which is usually seen as the physical components, but robotics is not only the physical components and anything which can automate a task like fully and understand its surrounding and its behavior, maybe from the data or maybe from its surrounding. That can be also a robotic process, but technically, traditionally, this turned out to be more physical than logical or logical system. Automation and robotics play a crucial role in making touchless supply chain possible. They involve using machines, robots, and computer systems to perform tasks that were traditionally done by humans. This helps us to minimize the human touch, and this helps us to run the operations like more effectively and accurately, with more safety and more reliability. Help us to this also like helps us to streamline the processes better than the humans can do. We can collect the data from the automation processes and the robotic processes, and that data can be used to improve them further. And possibly, we can also build some more layers on top of the automation or robotics that can make them way more intelligent. So there is always a iterative, continuous integration and development going on top of that on the basis of the data collected. Then the flexibility and adaptability also like plays a key role in the automation and robotics. IoT and sensor technology is one of the key aspects of the touchless supply chain, as they provide the real-time visibility. If you will place a sensor on a package, you can track it throughout its journey. It can also predict supply chain failures, probably on a production line level, in a warehouse, or maybe in a global supply chain. So you can foresee how that can happen actually if you are having if some of the package is moving from its geolocation, there is potentially some of the issue. Also, like smart inventory management systems can be there, which can actually track the inventories in the real time. Like, for example, you can potentially deploy some inventory management system on a rack level and in a store, and that will got a scan the inventory of specific products and will raise a alert or will update the stakeholders when the inventory goes beyond a certain level. Predictive maintenance also plays a significant role, and IoTs are the key enablers in the predictive maintenance. Predictive maintenance can be of your vehicles used in the supply chain, production lines, um, your computing instruments or something like that. Maybe you have other kind of heavy machinery or light machinery, whatever the kind of machinery is there you are using. So this can actually predict the maintenance schedules, and this can also predict the failures, like when a failure can occur within a machinery or something like that. Just to because when something fails, probably this will fail due to the fail, and this may cause a larger damage. That kind of damage can be prevented just by predicting the failure in the time, so that they can replace the components in the time, and they can prevent larger damages happening to those kind of machineries. Demand sensing and analysis is another aspect which where IoT and sensor technology can play a role, though this is not uh, used to its full scale in modern world. But there is a large like chance that this can be also used. Data analysis and AI actually plays a very important role in the enablement of the touchless supply chain. So if a touchless supply chain is using data and AI at its full scale, potentially they are very much touchless. Data analysis and AI have many angles, such as descriptive analysis, diagnostic analysis, predictive analysis, prescriptive, spatial, text, and network analysis. Particularly, diagnostic analysis involves the analysis of data to understand the root cause of the past events or trends on top of the descriptive analysis. Whereas predictive analysis can actually start looking in the future, and prescriptive analysis can actually start giving you some of the suggestions along with predicting something in the future. Spatial analysis is like more connected with the geolocation-based analysis. This can be a grid within a controlled area, or this can be global. You can use a GPS if you're tracking something on a global level. Text analysis can be like more useful when you are using some of the contractual data. maybe you want to scan the customer reviews or something like that. So textual analysis is like very important in that case. Network analysis, you can visualize this as a graph. The graph which connects the supply chain dots together globally can be like very useful. This can actually help to understand the flow of the supply chain from end to end, and you can potentially find the dependencies of single point of failures, and you can help. This can help you diversify the supply chains. This can help you to basically find the alternatives to a particular supplier site or something like that. When event like pandemic happened, um, this can be part of supply chain visibility, but supply chain visibility has a lot more to do than just network analysis. Supply chain visibility is uh, supply chain visibility technically focuses on the tracking and tracing of the movement of the goods throughout the supply chain, which uses IoT. This tracking of the devices can use barcodes, RFID, GPS, or something like that, as I earlier told. But supply chain visibility is not only limited to that. Supply chain visibility can also help us to visualize the whole supply chain globally, and so that you can actually find what's the single point of failures in the supply chain and how to diversify this into multiple regions of multiple geo regions on the earth, and how you can cut the costs globally by optimizing the movement of the goods and something like that basically. Also, supply chain visibility help us in the event monitoring. We can predict some of the failures, assume some of the supply chain route fails. In that scenario, supply chain visibility can actually help us to predict that route failure much in much in time, so that we can actually take the precautionary and preventive actions on top of that. Data integration is one of the key enablers of supply chain visibility, because we will need to have continuous access to the data in order to provide the supply chain visibility to its stakeholders. Real-time information is collected from the sensors and GPS tags or something like that, which is then synthesized using AI models or some descriptive data analysis models, just to get to know that what is basically happening on the supply chain level. So that helps a lot to a lot in the touchless supply chains to track the things which are otherwise very manual. Also, collaboration and communication is like one of the thing where supply chain visibility facilitates a lot. This allows stakeholder to share the relevant information, exchanges data, and collaborate on decision makings. This gives the same view to all of the stakeholders all across the globe. If you are using it through a central computational model, might be a cloud or something like that. So that way they are better able to synchronize on these kind of points. Contactless delivery and fulfillment in the order fulfillment part is like also very important aspect of touchless supply chains. This makes the touchless supply chains touchless in the real aspect. A touchless supply chain in a touchless supply chain, both order fulfillment and the last mile delivery are adapted to minimize physical contact and enhance the safety during the process of delivering products to customers. Last mile delivery is a final part of the order fulfillment process, where a product leaves the warehouse on the way to its final destination, which can be customer's home, office, or some other place. The key challenge of last mile delivery is to ship items as fast as possible while keeping the expenses down. AI can also power the customer service a lot, basically, uh, which means we can get the access to quick and accurate information. Also, we can this can have two faces, I think, two channels. One, customer service can actually help the customers. Definitely, they can ask a AI models such as large language model, which can actually respond to their queries along with the data, along with the right factual information captured from the database. But if you are not like giving the direct access to the customer to that large language model, possibly a customer rep who is just a new hire can also act as an experienced hire, because this has the basic access to the knowledge through from a large language model. This can put the question from the customer directly into that model, and then can get the answer, can make some improvement into that, and provide it back to the customer. So this way, this makes the experience like a lot better experience than some junior rep can actually provide in the real time. Okay, now we'll discuss some of the use cases of AI in the touchless supply chains. As we know that AI plays a significant role in enabling the touchless supply chain, and by automating the process, optimizing the operations, and providing intelligent insights and something like that. But before that, I think because AI enables a lot of things in the touchless supply chain, I think there are a lot of basically jargons which are around the touchless supply chains, and one of that is light out manufacturing, or the dark factories. So, do you know like what are these light out manufacturing and the dark factories? Light out manufacturing, or you can say lights off manufacturing, or the dark factories, are the factories basically which are completely automated. They don't require humans, or require minimum intervention from the humans, particularly on the maintenance part. uh, they These kind of factories uses total automation systems, robots, AI, and sensing and monitoring technologies all together in a way that human touch is minimized. Even human intervention is like minimized to a certain level. Benefits of the light out manufacturing is that this can increase the productivity a lot, improve the quality of the product, which can be very consistent on the quality side of the product, and cost saving, improve the safety, and also improve the flexibility and scalability of the systems. Fanuc is like a Japanese robotics company. I don't know if I'm like pronouncing its name correctly or not. Has been operating as a light out factory like since 2001. Robots are building other robots at a rate of like about 50 per 24-hour shift, and can run totally unsupervised for as long as 30 days at a time. Not only it is lights out, but they have also like turned off the air conditioning and heat as well, which is like kind of funny as well. But it could be like lost lot cost effective, I think, for them. In the Netherlands, Philips uses light out manufacturing process to produce the electric razors. They are using like multiple robots on the production line to basically do that work. uh, Only 9 or 10 humans are actually there for the quality assurance and the maintenance of the whole site. Amazon is also like one of the very modern space, which is using the technology very effectively, and which is using like robots into their distribution centers, and with minimal human interventions. When we're discussing Amazon, let's come to the warehouse automation. In the warehouses, robots are expected to help in many operations such as picking, packing, sorting, transporting, replenishing. Uh, there are many kinds of warehouse robots which are available on the market. Some are goods to person. There are two kinds of robots, one which are fully autonomous. Robots are normally fully autonomous. One which are basically which are used to assist the human there, and one which do not take the instructions to human, or which do not assist the human, but just simply keep on doing their job as per the instruction and they don't have like any of the interaction with the computer system. But these goods to person cobots and Sorters maybe are the ones which works alongside the persons, whereas autonomous mobile robots, AGVs, I don't think I have captured that name here, inventory trackers, autonomous forklifts, or something like that. These things doesn't work alongside the humans, but they basically move the things from one place, which is a dedicated place, to multiple places within the warehouse. Okay, for demand forecasting, I would want to tell you one of the use case which I have actually implemented in the past. Uh, I was I I was working with the company Tara, which is mid scale cattle feed manufacturing company located in India, with a strong commitment to providing high quality feed product to local dairy farms and other and farmers. Uh, we implemented this model there. Actually, I led the development of this demand forecasting and planning system. Demand forecasting is basically made up of three key components. One is base component, the demand which never changes over time, the demand which always stays the same. There are like this is not influenced by the promotions or the marketing or the sales activities you're doing. Second is the activity component, which you drive in by doing the marketing and sales. Another one are events, which you can say, such as Boxing Day in the US and Canada and Diwali in India, or some of the sporting event or something like that, which is of course not applicable in the cattle feed industry. The system which we built was using we used data analysis, demand calculation, demand prediction, and finally a judgment loop was added to the process to take the final decisions on top of it. We did a comprehensive data collection, gathered the historical sales data and market reports, weather records, and customer feedback. Though customer feedback was not available to that extent with us, it was a limited data. Using this data, we trained a ML model with shallow learning model, literally shallow learning model, specifically linear regression. The system did the analysis on the historical data, identified the patterns, and uses the external factors such as weather condition, milk production trends, and also some of the government reports from the state governments and from the central government in India, and that can influence the cattle feed consumption. Over the time, with the correct direction, we were able to basically collect more data, and with some trial and error, we were able to improve the accuracy of the forecast demand for, uh, for forecast demand system, which enable the planning team to plan their production schedules and inventory more effectively. One set of parameters that helps us a lot to a surprise, a lot to improve the accuracy, and that was to collect the demand signal from the channel partners and the retail partners. We had to convince our channel partners and our retail partners a lot, basically, to provide us with that data. So in the beginning, we started with a very small pilot, and then we eventually scaled that out to all of the partners. We built a workflow, which was a web-based workflow where we could collect the data on the weekly basis, monthly basis, or whatever the cadence we would want it to be. The system was able to bring remarkable improvement across various aspects of org operations. From the demand for forecast accuracy perspective, this reached the accuracy of approximately 70 to 75, which we were otherwise at 40-45 doing it manually. So this allowed the org to minimize the stock outs and reduces the excess stocks, and resulting in significant decrease in the storage cost and wastage. Also, this helped us a lot with the production planning, and inventory management also became a little bit more frictionless, more frictionless after deploying the demand forecasting model into the system. And cost saving is another aspect where we saved, I think, approximately 10 to 15% of the cost of total on a total. And with this everything, we experienced a remarkable experience increase in the partner satisfaction as well. Partner appreciated the timely availability of the right quantity and the quality of the product, which helped us to improve the market share in the certain areas. Partners were happy, and we gained like more partners in the market by deploying a very simple demand for forecasting model. Uh, this gives us an insight that you do not always like need to build very complex models based on very complex machine learnings and very complex feature embeddings. You can build some very easy models which actually in turn brings a very good result to fore. Apart from demand forecasting, I also built a predictive maintenance model with them as well. Predictive maintenance model was basically using the sensor data from the equipments. Like we have a the production line was using actually multiple stages. The multiple stages was like when the raw input when the raw input comes on the production line, then this goes under the crushing, mixing, pelletizing, cooling, crumbling, sieving, packaging, and boxing. So throughout this process, we had multiple stages, and many of the failures could occur at different kind of stages, and which actually brings down the whole production line. So in this case, like we had to basically come up with some system which could actually predict the breakdown of the system of some of the component, and hence predict the like breakdown of the overall production line. Uh, Okay, let's not dig deeper into this, but on a high level, this all of these individual stages within the production line can are acting as a point of failure. So the failure in any of the components will actually halt the production process. Each of the component has different inspection times. Some components are easy to repair, whereas others takes a long time. Now, we could follow two approaches into that particular solution. One was to predict the failure of each component separately, and not at the production line level. But that will also tell us that whenever some of the component is failing, this means whole of the production line is failing. So this will actually fragment the classes for the machine learning model. Another approach is to classify the failure first as yes or no on the production line level, and then go down to the component level, and then basically find which particular component is going to fail according to the data we are observing from the sensors. Uh, we implemented the second approach, which was multi-level approach, but this is always like dependent on the use cases, like what kind of use cases there. But we had a lot of issues while we were implementing this solution. The first issue was the false alarm, because we deployed a buzzer on the production line, and whenever a false alarm goes off, the buzzer was going on. So someone had to come in and had to basically look at the component which this machine learning has predicted is going to fail. So willingness of the management was very important, because in the beginning we were actually more of an obstacle than a help. This also increased the cost and increased the maintenance time as well in the beginning. But eventually, and also like we were experiencing some of the problem from not only from the false positive, but also from the false negative predictions as well, when our machine learning model didn't basically predict anything, and but the production line went down. So those kind of things also had to be fixed down the line, and eventually everything gets optimized down the line. But this is like the journey of the machine learning model. Um, over Overfitting or underfitting is another problem, where your model overfits to a particular category and do not predict the values for others well. So this happens a lot, because whenever you are making a predictive maintenance models, your data is like very imbalanced, because you have a lot of data for the periods when production line is not failing, but you have less data for the periods when the production line is actually failing. So there's a lot of imbalance, and you should be able to handle that imbalance perfectly on the for a machine learning algorithm by possibly fine-tuning the parameters by selecting the right features or something like that. Uh, to build a successful predictive maintenance model, we had to go through a lot of actually trial and errors and learnings iteratively in order to come up with the sufficient accuracy level where it could actually help us start to save some of the money rather than incurring more costs, as I have just told you what was happening with us. Um, Route optimization is another aspect of touchless supply chain where AI is like very useful. I am personally very interested in the route optimization algorithms like since quite some time. Uh, one use case which I always see is the UPS use case. UPS started avoiding the left turns in 1970s when they come up with a method called loop dispatch. uh, Plotting they were basically plotting a loop which were taking most of the right turns and not the and avoiding the left turns as much as possible, and starting with one side of the street first and then going down the line just by taking the right turns as much as they could. Down the line they had to basically convert this route optimization into a machine learning problem, and that system is called Orion. They deployed that system in 2008, and I think this took almost 10 years for them to optimize that to a optimum level where this could actually start to help them. uh, the I have basically captured some of the numbers from the implementation cost of the system. That was approximately 250 million in total, and that was expected to save approximately 300 to 400 million every year, which is a good trade-off from the cost optimization perspective. Nowadays, we can see route optimization software is almost everywhere in a cab solution like Uber and fast food delivery giants like Zomato, Swiggy in India, and like there are many other options like that. Supplier management is another aspect where AI can actually help the touchless supply chains a lot by doing the supplier selection and qualification, by doing supplier performance monitoring, demand for forecasting, uh, and risk assessment and performance management, and also like supplier collaboration and stuff. Okay. In the next section, we will go on how a BA can play a role in enabling the touchless supply chain, particularly in enabling an AI solution within the touchless supply chain. So I'm like focusing on that particular piece, though BAs have a very good role to play in all of the AI projects by using their conventional work, because I don't think anyone else can substitute BAs work, because BAs are pretty much tied between the business stakeholders and the technical teams, where both of them are not able to comprehend the things in the same way as a BA can. So definitely BAs play a very important role there, but particularly when you are enabling AI-backed solutions in the touchless supply chain, a BA should have a general understanding of AI. So a BA must understand AI, ML, and its types. AI/ML has typical four types like supervised learning, clustering, semi-supervised, and then reinforcement learning. So you should know like which type of problem this is, and which type of which type of set of algorithms can be applied to solve this problem. Uh, a general assessment can be also done if this problem only require a RPA automation, or this require actual AI/ML modeling. For a RPA process, you can use you can use the very traditional tools such as UiPath, Power Automate, or also I will say Zapier or BotPress nowadays. They are also actually very helpful, though it's like little bit debatable that Zapier is a RPA tool or not, but still I will say I will consider this as a RPA tool for sure. Um, And readiness assessment is a basic assessment of a org to deploy some of the AI solutions, which will actually include the willingness of the management, data literacy, talent availability, data availability, and then the technical capability of the person and the org as a whole. Supply chain expertise also plays a big role. If a BA has a supply chain SME, they can have comprehensive knowledge about the processes, and hence they can play an important role in building good solutions. These BAs can provide expert guidance for the technical team or business questions, and these BAs can also contribute in identifying the potential upper opportunities in the workflows, as because they understand them inside out. These BAs can also help to do the analysis of supply chain readiness for AI solution from a better perspective. AI expertise. If some of the BA can actually bring AI expertise onto the table, that BA can be very helpful for the AI/ML team as well as the business, because this BA can actually bring both SME and supply chain and AI on the table, and can not only help with the solution brainstorming, but can also identify the potential risk associated with AI/ML behavior, such as overfitting, underfitting, bias, variance, trade-offs, hallucinations in the case of large language models and something like that. This BA can effectively bridge the gap between AI engineers and business stakeholders. This BA can definitely help explain the complex AI functionality to the stakeholders in very simple languages. So, by actively like participating in the enablement of intelligent solutions, business BAs can ensure that touchless supply chain leverage the solutions, modern solutions like IoT, AI/ML, and other technologies effectively. They contribute to the successful implementation, optimization, and value generation of these solutions, and leading to improved operational efficiency, improved decision making, and better customer experiences. We as BA, we all have a role to play in the evolution of touchless supply chains, or you can say supply chain 4.0. So that is my topic. Thank you so much. And please, if you have any questions, please feel free to ask. Thank you.
Thank you, Ajip. This subject is fascinating. Thank you. We have some questions here, and we have some time. So the first question is, what case of AI application in touchless supply chain do you find the most fascinating from your point of view?
Uh, I would say demand forecasting is like one of those which I always say that a touchless supply chain can always basically implement in the beginning. Demand forecasting, actually, if a supply chain already have a demand forecasting framework, they can potentially convert it into a AI backed framework as well, and they can basically convert it into a intelligent like demand forecasting model, where this can predict the pockets where the demand is not getting forecasted correctly, because demand forecasting is very mixed model. You cannot eliminate the humans entirely from the demand forecasting, I think. So yeah, this is like one predictive maintenance. And in the supply chains, we have actually a lot of opportunities to apply AI/ML, and there are some potential opportunities which we now cannot imagine. But with the emergence of the large language models, I think I can foresee a lot of basically applications coming in the same direction as well. Yeah.
Thank you. So the next question. Is it mandatory to incorporate machine learning into demand forecasting models? What is your opinion?
I would say no. Uh, Machine learning models are not essential for the demand forecasting, because demand forecasting can be actually done by using the simple by collecting the demand signal from various pods and partner channels or something like that as well. But machine learning models should be deployed when we have some of the black boxes from where we are not able to predict the demand into. So we can use that kind of behavior to predict the demand into that boxes, and that way we will have like much better visibility of the demand. So I think that will be a better approach when we will be using the demand signal plus machine learning model to basically forecast the overall demand.
And the next one, can we develop a maintenance forecasting model without IoT data?
It's a tricky question. I would say not essentially, but yeah, if you differentiate IoT from sensors on the basis of their connectivity, then yes, you can say yes, you can also deploy the predictive maintenance model based on the sensors only. But when I say sensors, I usually see them as a IoT in the modern world, because who can otherwise like go and collect the data from a sensor to sensor? So in that case, I think yeah, kind of IoT plays the right role in the predictive maintenance models, because you always like need to continue collect the data in the real time from those sensors, in order to build those models, right? So IoT without IoT, it's almost like impossible to build a right predictive maintenance model, I would say.
Okay, thank you, Ajib. I don't see any more questions. But please, dear audience, we put two links in the chat. One of them is please suggest topics to the next conference, and another one to please give us your feedback. We will appreciate it. Ajib, thank you so much for your presentation. It was very interesting, very valuable. And the next conference that we will have is 9 minutes from now, Navigating the AI Revolution, 5 essential mindsets for business analytics to thrive. So don't miss it. And as we don't have any more questions, we will end this presentation here. Thank you again, Ajib. See you next time. And please, audience, keep with us to the next presentation.
Thank you, everyone. Thanks.
Thank
Thanks
you.
for joining. Bye.